Hello everyone, my name is Dr. Travis Ford. I'm here to analyze our soil and plant tissue analysis that we got from our research test plots. Today we're going to start off with our soil analysis here. So we have our results back from the lab, and the first thing we'd like to look at is our pH level in the field. So we can see here our pH level is 6.1, which is slightly lower than we would prefer. The optimal range for pH is approximately 6.3 to 6.5 for cereal grains such as corn, soybeans, and winter wheat. Now, if you're doing a different crop such as alfalfa, you're going to want that in the low 7s, like 7.3 is the optimum pH. So depending on the crop you're growing, you're going to want to look at that pH analysis. And that's going to basically allow your nutrients to be more available to the crop and give you better fertility and increase your yield potential for that crop. So one of the things we can see here is we have a 6.1 pH. Then we can go and look at our NP and K. So for our nitrate levels, we are at 21.5 parts per million. Our ammonium, which is our immobile nitrogen source, is 6.4 parts per million. We have a phosphorus level at 218 parts per million. And we have a potassium level at 168 parts per million. And when you look at these levels, your lab's going to give you a deficient, low, a sufficient, or a high range typically for those. And we are sufficient or high in all of these NP and K nutrients. And so then we'll start looking at our micronutrients and seeing where we're at with our levels of micronutrients. When we quickly look through here, most of them look pretty good, but we can see one is deficient, and that is in boron. Boron's essential for the plant, so increasing the levels of boron, in this case, probably increase our yield potential, as it looks like boron would probably be a limiting factor in that field. And then we can also look at some of our other micronutrients, such as zinc, manganese, copper. And we can also take a look at our macronutrients, such as calcium, magnesium, and sulfur. Again, these are all essential nutrients for the plant. And we want to make sure that we're optimizing our yield potential by making sure the ratios and the level of these nutrients are in the correct areas for the crop that we're growing. Another aspect that we'd like to really focus on is our base saturation percentage. Base saturation percentage is going to give you the percentage of cations in your soil. So the percentage is going to add up to 100%, and we're going to be looking at hydrogen, potassium, calcium, magnesium, and sodium. So those are the 5 cations that we're going to be looking at in the base saturation test. And now we're looking for specific ratios to optimize our fertility in the field. So for hydrogen, we're going to want our levels to be approximately less than 10%. Sodium, we want less than 1%. Calcium, we like in the range from 65 to 80%. Magnesium, we like somewhere between 12 and 25%. And potassium, we like 4 to 8%. Now, these numbers aren't hard and fast numbers that have to be strictly followed. But if you have soil that's within those ranges, you're going to be optimizing your fertility in those areas. A couple things that you can kind of think about with your base saturation. Here on the Eastern Shore, we typically have light sandy soils. In our northern Maryland and southern Pennsylvania region, we can have a little bit of heavier soils. So managing those different soil types can be really important in looking at your base percentage saturation on these cations. Can help you identify which nutrients you need to supplement in the field to kind of help your fertility levels. So for a lighter, sandier soil on the Eastern Shore, you're going to want to try to increase your magnesium levels if you're at a lower magnesium base percentage. Say if you're somewhere in that lower range around 12% and you have a light, sandy soil, increasing your magnesium levels will help give you a heavier soil and get rid of some of that lightness that you have in your soil. And conversely, so if you have a heavier soil and you're increasing your calcium levels, that'll help lighten that soil up and give you better porosity. And so there's a number of things you can look at with your soil analysis that can basically help you with your fertility across across your field. So one of the interesting things that we found from our research plot was that we had a location, and like I said, we had a 6.1 pH. And then when we go into our tissue analysis to see how our tissue analysis is faring, we took tissue analyses from 3 different zones in the field from our 3 different treatments. So we had a treatment where we banded fertilizer, we had a treatment where we dosed fertilizer with the exact shot and an equivalent rate, and then we dosed half rate. And so we can look at our nutrient levels in those different treatment zones to see if we're seeing any differences in nutrients in those plant levels. So one of the things that we see here was we took tissue analysis at approximately the V5 corn growth stage, and we look here at our levels of nutrients across the board, and we'll quickly look at a couple of the deficient and low nutrients. So we're deficient in nitrogen. This was before our side dress nitrogen application. So again, you can use this for a pre-side dress nitrate test, which will help you identify how much nitrogen to apply in the field. You can also look here, our phosphorus levels were a little bit low. We had low zinc levels, and we had low boron levels. Now the boron levels we expected would probably be low since we were low in the soil analysis. But if we look at our phosphorus, we actually have high phosphorus levels in the soil. And if you're familiar with the UMD FIV levels of phosphorus, which is the phosphorus management levels for the Maryland and Mid-Atlantic region that we use to decide how much phosphorus can be applied to a particular field. If you go above 150 FIV, you're limited to how much phosphorus you can actually apply to the field. And we have a UMD phosphorus FIV of 240. So we're well above the threshold for limiting how much phosphorus we can put down. But when we look at the plant tissue analysis, we're low in phosphorus. And so we kind of question, why would we be high in phosphorus in the soil, but low in phosphorus in the tissue analysis? Now, the tissue analysis is a snapshot of the crop on that specific day at that specific time. And so these levels can change throughout the growing season. So it's good to monitor the tissue analysis throughout the year to see if the patterns are continuing. If you do get a low phosphorus level in one tissue analysis, but then the other subsequent tissue analysis aren't showing low phosphorus levels, you can maybe think that that could have been an environmental factor for that specific time. So we're going to follow up with these tissue analysis to see if we're still low on phosphorus. But with one test, we can kind of go in here and try to understand why there's the potential that we have this low phosphorus levels. And when we start to really analyze our soil analysis, even though we have a high phosphorus FIV value, our pH is a little bit lower than we would like at 6.1. Optimum pH range would be 6.3 to 6.5 for the corn that we're growing. When you start to get a lower pH such as 6.1 or even lower than that, if you go into the 5s, what begins to happen is you have aluminum and iron start binding to your phosphate. So you get what's called iron phosphates and aluminum phosphate compounds. And so if we look down here, we have an aluminum level of approximately 1,000 parts per million, which is higher. And then we have an iron parts per million of 140, which isn't particularly high. But because we have this 6.1 pH, it starts to make phosphorus and aluminum bind together and becomes less available to the crop. So this is a potential area that we have for a liming application that would help our nutrient availability. So if we were to go out here and lime this field and bring up that pH to between 6.3 and 6.5, we would expect that phosphorus would become a little bit more available, and we would likely not see the deficient phosphorus tissue that we see now. But again, we're going to do subsequent tissue analysis and see if this holds true for the rest of the season. And if so, we're definitely going to be looking at liming that field for the next season to improve our crop fertility levels. Another interesting aspect that we found from our soil and plant tissue analysis was that in our different treatment levels where we had a banded in-furrow, a dosed in-furrow equivalent, and a half-rate dosed with our exact shot. And the dosed fertilizer application is just being applied to each seed as it's planted in the ground. And like we talked about, we had high phosphorus levels in our soil analysis, but we actually had low phosphorus levels in our tissue. And then we're also seeing, because we used a 316-18 fertilizer pop-up blend, that phosphorus is available more to the crops that have some of that phosphorus tie up in the soil due to the low pH. So we're actually seeing a decrease in phosphorus in our tissue analysis. Our banded and our dosed in-furrow treatments that were equivalent, there wasn't too much of a difference in our phosphorus percentage. We had a 0.33 percentage in our banded treatment, and then in our dosed equivalent we had a 0.3, so slightly lower, so it is a decrease. And then when we look at our half rate equivalent of that pop-up, we decreased down to a 0.26 percentage on that phosphorus. So we are seeing where we have some phosphorus tie up, we are seeing slight differences in that phosphorus level in the tissues based on our in-furrow fertilizer treatments. So we had another field that was low and deficient in our potassium levels. So we had a 30 part per million in our potassium levels. And one of the key things with potassium that many people don't realize is, specifically for corn, is that corn is actually going to use more potassium than nitrogen throughout the growing season. It's just going to leave more of it in the field. So the potassium will be left over in the stover, which gets put back into the field, where nitrogen, a lot of it's taken out in the grain. So you'll take out more nitrogen in the field, but a corn crop will use more potassium throughout its growth season. And so potassium is a really, really important nutrient for corn growth. It's super big and important for water transport throughout the stomata of the plant, and also helps carry other nutrients into the plant as well. So when we look here, we have a low potassium level. And then when we look at our plant tissue analysis, we have 3 different plant tissue analysis. And when we look at our banded, we are sufficient in potassium. So we banded 18% potassium fertilizer, or 316-18. And then when we look at our equivalent dosed pop-up fertilizer treatment, we decrease down to 3.2 percentage. So we go from 4% to 3.2%. And then our half rate dose, we go down to 2.49. So we can see here in a field where we have deficient potassium levels, that total amount of potassium is having an impact on how much is actually being uptaken into the plant. Now here in the Mid-Atlantic region, we have somewhat lighter soils, so potassium can move around a little bit more readily in the soil than say some heavier soils from the Midwest. But if we look at phosphorus, where phosphorus is highly immobile in our soils, you don't see as much phosphorus differences based off of the tissue analysis that we saw in the deficient soil. And that's because the phosphorus doesn't move around as much. And so when we place the phosphorus directly on the seed, it's going to be more available to that seed crop, and it's not going to be tied up in the soil quite as much. Now potassium has the ability to move around a little bit, so that difference is going to be a little bit more than we would see in our phosphorus levels. Now again, with our soil analysis at our other field, we like to look at our pH, which is 6.7, slightly higher than we would like, but we're still well within the 6.5 to 6.8 range. If we go ahead and look at our NP and K, again, we are low in nitrogen. This was before our side dress nitrogen application, so we would expect to be low. We're low in potassium, so a potassium application would probably increase our fertility and yield potential in this field. We are also low in some micronutrients such as boron and sulfur as well. If you look here at our potassium base saturation at 1%, that's extremely low. We want that range to be in the 4 to 8% range. So increasing our potassium in the field would really help increase our yield potential. If we look at our magnesium, we're at 12%, that's not bad. Calcium is slightly high at 81, but we're still pretty close. We'd really just like to increase our potassium here. And then when we start to look at our other macro and micronutrients such as calcium, we're pretty good with calcium, we're pretty good with magnesium, and we have a decent ratio of calcium to magnesium that we'd like to see. We have pretty good manganese levels. So again, the few key things to focus on here would be potassium, boron, and sulfur for this test. And then we can increase our fertility levels. All right, so one of the things that we talked about with soil sampling was analyzing our analysis levels of the results. But another good thing to talk about when you're soil sampling is the actual type of sampling that you're going to be doing. We're doing composite sampling on our research fields. We have approximately 20-acre fields, and it's good to do composite on those fields just so we can get a baseline average. And we're not trying to do variable rate applications or anything like that. So doing grid soil sampling isn't going to help us do variable rate across our research plots. But as an active farmer, doing grid soil sampling would be highly beneficial, because then you can look at doing variable rate applications of lime and different nutrients. So in the past, I've done 1-acre grid soil sampling on different fields. Here we have a 20-acre field where we did 1-acre grid soil sampling on phosphorus levels, and you can see just how much variance across this 20-acre field there is from doing 1-acre grid soil samples. And from our phosphorus levels here, we had a low of 84 parts per million and a high of almost 300 parts per million. So we're talking a range of really 220 parts per million almost phosphorus levels across the field, which is quite a bit. And if you were to take the average of this field, you're going to be somewhere between 150 and 200 parts per million, which is really going to give you a really big standard deviation across the field, which isn't going to be good if you're applying a flat rate of anything across the field, because you're going to end up with many areas that are getting either too little product and then many areas that are getting too much product, and you're not going to have a whole lot of area that's actually getting the right amount of product. And this feeds into the 4 R's principle of precision agriculture, which talks about the right product at the right time, with the right amount, at the right place. If we follow that 4R principles, we can really start to do some variable rate applications with soil sampling. With Operations Center, you can upload shape files of these soil samples to do prescription maps. So if you look here, we could upload a shape file of these points and the levels of nutrients. We can map the field so we can get an idea of what the field looks like, and we can kind of visually see the differences across the field. And we can do this for NP and K. We can also do it for all the micronutrients, and we can also do it for lime applications as well. And the return on investment on this is really good. Being able to increase your fertility levels across the field, and you also really get to understand how much variance across a farm field you will have. Even on small fields, you'll have a good level of variation, and your nutrients will vary considerably across that field. If you were to be able to do variable rate application using Operations Center through John Deere, you can greatly increase your productivity, efficiency, and your overall ROI. And so that's one thing to really think about when you're doing soil sampling, is that if you've never done grid soil sampling, at least try it once. 1-acre grids are really good, but if you don't want to do 1-acre grids and you don't have the time for that, you could do 2-acre grids, 5-acre grids, whatever you feel comfortable doing. And again, as you get those grids smaller, you're going to really see the variation come into play. And you can do a lot of variable rate applications to help increase your fertility across the field. Lime application is key. So if we look at our pH levels across the field, you're going to see various levels of pH ranging from the low 6s all the way to high 6s. And varying that lime application will help really maximize your potential with pH. And when you dial that pH in, it really increases your nutrient availability across the field. And that greatly impacts how much yield you can have.